Hi, good morning, good morning. Hi, good morning, good morning. No one is saying anything. Good morning, good morning, good morning, good morning, good morning, good morning. Yeah, good morning, good morning, good morning. Bagunnara. Good morning, good morning, good morning, good morning. Yeah, Bagunnara, everyone manchi at home. Yeah, okay, very good, very good, very good. So what's going on at home? I'm also Manchi. If students are Manchi, teacher will be also Manchi. Directly proportional. If a student is happy, teacher is also happy. If students are sad, teacher is also sad. So directly proportional. Yeah. So what's going on at home? Chilling or studying? Acha, chilling, sir. We are doing chilling, sir. But we are doing chilling with studying. Yeah. Okay, no problem. Chilling with studying, we are doing different type of chill. We are legends, sir. Normal kids chill with movies, normal kids chill with web series, normal kids chill with roaming here and there. We are ultra pro legends, not ultra legends, ultra pro legends. We chill, but we chill with study. Yeah, okay, no problem, no problem. Okay, so shall we start with the class? Shuru kare kya? Shall we start with the class? Shuru kare. So what we studied in the last class, in YouTube, it will be stopped very soon. I think maximum this week. This week it will be going on YouTube. After that, Zoom will be also stopped. We'll have class on the app. Yeah. So I think in last class we were talking about river boat problem and then river swimmer problem also we talk. Nadi Ithagadu Samasya. Nadi Ithagadu Samasya. After a long time, I learned new word. Yeah. Ithagadu. Ithagadu means swimmer. Yeah. Is it okay? So we were talking about, so what was the condition for swimmer to reach exactly opposite point? We studied the condition. What is the condition to reach exactly opposite point? One condition we studied, VA sine theta equal to VR. If one component of swimmer velocity cancels the river flow, then we will say swimmer will reach exactly opposite point, that is VA sine theta equal to VR. Achha, what was the time for crossing the river in that case? What was the time? General formula for time. W by Vs cos theta. Yeah, W by Vs cos theta. W by Vs cos theta. Okay, no problem. Achha, you tell me, what will be angle with the flow? Right now we are talking about angle with the normal. If anyone asks you angle with the flow, 90 plus theta. Yeah, very good, very good. Everyone remembered each and every point. Very good, very good. Yeah, okay, no problem. Achha, if anyone asks you, if swimmer has to cross the river in minimum time, what will be that minimum time? What is the minimum possible time for a swimmer to cross the river? W by Vs. W by Vs. Yeah. And what will be drift of swimmer in that case? What will be drift of the swimmer in that case? Velocity of drift into time. Velocity of drift means velocity of the river, because river is responsible for the drift. So we are into T. Yeah, we are into T. T is W by Vs. So we are into W by Vs. Yeah. Okay, no problem. No problem. Yeah. And how swimmer will swim in that case? How swimmer will swim? How swimmer will swim? Perpendicular to the river flow, normal to the river flow. Swimmer will swim perpendicular to the river flow, normal to the river flow, or you can say due north. We can also say due north if you talk in the terms of east, west, north, south. Due north. Yeah, okay, no problem, no problem. So everyone understood all these points? Done. Questions you practiced, practice of question done. Practice is very important. You have to do the practice of the question also. Okay, no problem, no problem. Yeah. So everyone got all this thing. One last thing I will talk there, then we'll move further. Then we will complete our this chapter and we'll start with our chapter Newton's laws of motion. One last thing I will talk just here. Okay, no problem. No problem. Just here. Yeah. Okay, no problem. This is not very important. Actually, rainboat. Yeah, there. Rainboat and river main problem is there. All those are there. I think syllabus sent to you, this week's syllabus. This week's syllabus sent? Not yet, sir. Okay, it will be sent. Or if it is sent, some change has been happened in the syllabus. Prasadji was not knowing that. Okay, no problem. Yeah, it is there. Riverboat problem is also there and rain man problem is there. It is there. Okay, sent now, sir. Okay, no problem. No problem. I will check the syllabus, but actually syllabus changed. He was not knowing about that. Okay, no problem. So let's start. Acha, one thing I will talk about, just one thing, which is not very important. But still, this will give you more understanding of the river swimmer problem. So that's why I'm talking about this situation. Assume, yeah, okay, no problem. Assume this is the river which we are talking in the last class also. Assume your river is flowing with velocity VR. Okay, no problem. Velocity of the river is flowing with velocity VR. Swimmer is here. Swimmer can swim in still water. Actual velocity of the swimmer. Okay, no problem. You can ask that thing at the last. Actual velocity of the swimmer is Vs. Okay, no problem. I said you, for example, assume if your swimmer is swimming at an angle theta with the normal to the river flow. You tell me if, and this is point A, this is point B. You tell me if Vs sine theta becomes equal to Vr. Can you tell me which point swimmer will reach? If Vs sine theta becomes equal to Vr, exactly opposite point. This is what we studied in the last class. In this situation, the swimmer will reach exactly opposite point. Yeah, exactly opposite point means exactly at point B. Exactly at B. Our swimmer will reach exactly at B. But assume a situation, if Vs sine theta becomes more than Vr, here drift of the swimmer will be zero. Exactly at point B means swimmer will not drift. But assume a situation, if Vs sine theta becomes more than Vr, then where he will reach? Here drift is zero because exactly opposite point, no drift. But if Vs sine theta becomes more than Vr, then where he will reach? Left of B or right of B or exactly B? Left of B. Always remember, this is what I was telling you in the last class. When these two velocities become equal, now when Vs sine theta becomes equal to Vr, net velocity of the swimmer in this direction becomes zero. When these two velocities become equal, net velocity in this direction, river flow direction, net velocity become zero. That's why swimmer reaches exactly point B. But if your Vs sine theta becomes more than Vr, that means if this velocity is more than Vr, your swimmer will have net velocity in this direction. It's like upstream. You can say this is like your upstream. So if someone says, sir, if Vs sine theta becomes more than Vr, then what will happen? Your swimmer will have, for example, if Vs sine theta is 4 and Vr is 3. So what will happen? Your swimmer will have net velocity in this direction. 4 minus 3, that is 1. So always remember, if Vs sine theta becomes more than Vr, your swimmer will reach on the left of B. Left of B. And you can also find the drift. You can also find how much drift, where he will reach. This distance also you can find. And this distance will be coming as velocity of drift into time. Again, same concept, velocity of drift into time. And what is the velocity of drift here? What is the velocity of drift here? Tell me. With how much velocity he will drift? Vs sine theta minus Vr. Arey Baba, Vs sine theta is his velocity. River is opposing. So what net velocity he will have in this direction? That is Vs sine theta minus Vr into T. T you know. T already you know. W by Vs cos theta. Vs cos theta will be only involved in crossing the river. कुछ समझ में आया क्या? Did you got the idea? बोलो बोलो बोलो. When both are equal, if you put both equal, you'll find that drift is zero. If you both are equal, if you put there both equal, what will happen? They will cancel each other and your drift will become zero. That's why when both are equal, your drift is coming zero. Done, done, done. You tell me the next one. If someone says, sir, if Vs sine theta is less than Vr, then where swimmer will go? Can you tell me? Left of B or right of B? Now swimmer velocity is in this direction, but it is less. So still river will push him. So in this situation, your swimmer will go on right of B. Right of B. And again you can find drift. Drift, if anyone asks you, drift means velocity of drift into time. And velocity of drift you can find. Here it will become Vs is like, Vr is like this, Vs sine theta is like this. So if Vr is more, swimmer will have net velocity in this direction. That is Vr minus Vs sine theta. Into time. Time is decided by V cos theta. That is W by V cos theta. Vs cos theta. Done. बोलो 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 बोलो. मनोगना not VS sin theta plus VR बाबा, both are reverse. देखो ध्यान से, VS sin theta and VR both are opposite. If VS sin theta is more, you write VS sin theta minus VR. When VR is more, VR minus VS sin theta. Everyone got the idea? Yeah, okay, no problem, no problem. Yeah, okay, very good. But these are not important. Question is asked mainly for those two cases. Reaching exactly opposite point and crossing the river in minimum possible time. Acha, if you understood this question will check how much you understood. Assume situation. If our swimmer is swimming like this, can you tell me what will be drift? Our swimmer is swimming like this, river is flowing like this. Can you tell me what will be drift now? W is the width. You can watch, if you are absent in the last class, you can watch on YouTube. Class is there. Now what will be drift? Now you will say, now if you see here, now very good. Gayatri, very good. Gayatri, very good. Now you will simply say, sir, now here velocity of the swimmer has again two component. So this is Vs, this is theta. So this component is, sir, Vs sin theta. This is Vs cos theta. Always remember, Vs cos theta is responsible for crossing the river. But if you see now, it's like downstream. Your Vs sin theta and Vr both are in the same direction. So velocity of the drift, if anyone asks you drift, where drift will come, velocity of drift into time. Now if you see here your swimmer will drift due to both of them. His own velocity is in the direction of river flow and river flow is also in the same direction. So net velocity of drift will become Vs sin theta plus Vr into T. T, you know, this Vs cos theta will decide T. So distance by speed, W by Vs cos theta. Done? Bolo, 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 bolo. Arey, kuch samjhe. But this will not come in your NEET. In NEET, question is asked from those two cases. This is just for your understanding, I said. This situation is like downstream. In this direction, downstream. If you see, this was like upstream. That's why you are subtracting. Because if you see, this component is against the river flow. That's why it was in upstream. That is VB minus VR. This was like downstream. Because VS sin theta and VR both are in the same direction. Shall we finish out this chapter and jump towards the new chapter? Aage badhe kya? Yeah, now we'll start with our next chapter. We'll start with our next chapter. You can write Newton's laws of motion. You can write the name of chapter, Newton's laws of motion. Newton's laws of motion. N I have written in a very stylish manner. First time I have written N like that. Yeah, I am also feeling proud of myself. So nice N I have written. Yeah. Okay, no problem, no problem. Newton's laws of motion. Yeah, thank you. Yeah, okay, people are praising me, so thank you. Yeah. So now we are going to start. Achha, do you know one tricky part here? We say Newton's laws of motion, but these laws are not given by Newton. Who gave these laws? You know, we say Newton's laws of motion, but these laws are not given by Newton. Who gave these laws? These are given by Newton only, Baba. Hey Bhagwan, I was just trying. You believed also. Why the name will be Newton's laws of motion? Of course, these are given by Newton only. Yeah. Okay. I was just checking your presence of mind. Yeah. Okay. You started saying, sir, Einstein. Someone is saying Galileo. And Newton's laws of motion are given by Newton only. Okay, no problem. How many laws we have? Acha, by me. For you, it is by me. Yeah, okay, very good. No problem. We have three laws. Three laws are there. Acha, which is your favorite law out of these three laws? Which law is your favorite? Third law. What is third law? To every action, there is equal and opposite reaction. Action-reaction pair. Action-reaction pair. To every action, there is equal and opposite reaction. Yeah. If I slap my cheek, so force will act on my hand also, force will act on my cheek also, and both forces acting are equal and opposite. If you drop a ball on the ground, force will act on the ball also, force will act on the ground also. Both forces will be equal and opposite. Is it okay? Is it okay? Third law. Now, okay. Now questions, if you talk about NEET, in NEET if you talk about, yeah, okay, very good, no problem, huh? Okay, you see, already you are studying Newton's laws of motion from class 9th also you studied, class 11th also studied, board exam also you did. Questions from Newton's first law are asked already in class 9th. For example, if a car suddenly starts, we feel back. When car suddenly stop, we go forward. Have you seen all these questions? Yeah, this is due to these are all the theoretical questions which we studied in class 9th. 10th. In NEET, question asked will be numerical, and numerical means value of force. Numerical means value of force. From which law we get the value of force? Second law, Newton's second law. Our main target will be to talk about Newton's second law, but you can write one point. You tell me, what is inertia? What is inertia? What is inertia? What is inertia? Resistance to the change. Inertia is the resistance to the change. So this is Newton's first law. Actually, first law tells us about inertia. Always remember, just for 5 minutes I will talk about this first law. Okay, no problem. Always remember, everybody wants to continue its initial state of rest or motion or direction. We have 3 types of inertia: inertia of motion, and inertia of direction. So everybody wants to continue its initial state of rest or motion or direction by a property. Name of that property is inertia. In the morning when your mom asks you to wake up, you don't wake up. It's not due to your laziness, it's due to inertia. Tell to mom next time when she comes to make you awake in the morning, tell to us, mom, I'm not waking up because I have inertia of sleeping. It is due to inertia. If I'm sleeping, I want to sleep. Are you getting? This is a good explanation I'm giving you. If mom says, tell to her, then she will apply external agent. External agent means, yeah, projectile. That flying chappal will come, flying water will come, stick will come. That is your external agent. After that, you wake up. Yeah. So always remember, problem is not with you. If you are sleeping, you will always want to sleep because you have inertia there. Because you don't want to change initial state. If you want to disturb that initial state, you require external agent. External agent means external force. So you can write this small point. Inertia is the property by which everybody wants to continue. Inertia is the property by which everybody wants to continue its initial state. Inertia is the property by which everybody wants to continue its initial state of rest or motion or direction. Inertia is the property by which everybody wants to continue its initial state of rest or motion or direction. Acha, who will have more inertia, me or Pansar? Who will have more inertia, me or Pansar? Can you guess who will have more inertia, me or Pansar? Pansar will have, Baba. Who is saying? Sindhu is saying you. How? Yeah. Why Pansar will have more inertia? Can you tell? Mass. He's married. Wow, nice answer, Aswak. Yeah. Always remember, inertia is decided by mass of the body. Greater the mass, greater will be the inertia. That's why you see the fat people feel lots of laziness while waking up from the bed. So always remember, you write this. Inertia is directly proportional to mass. Inertia is directly proportional to mass. Inertia is directly proportional to mass. Acha, for disturbing inertia, what we require? For disturbing inertia, what we require? For disturbing external agent. That external agent is force. That external agent is force. So always remember Newton's first law. Actually, if you see carefully, if you want to really understand what happens, actually Newton's first law defines force. It says everybody wants to continue its initial state of rest, motion, or direction. If you want to disturb, you have to apply external agent. That external agent is known as force. Actually, Newton's first law is definition of force. Newton's second law is value of force. Newton's third law is nature of force. That force will always exist in action-reaction pair. Are you getting my point? Are you getting my point? That external agent is defined as force. So first law gives us definition of force, second law gives us value of force, and third law gives us nature of force. That force will always exist in action-reaction pair. Those action reactions will be equal and opposite. Now you write second law. We will move towards the value of force, from where numericals will come. Second law. Second law. And what second law says? What second law says? Force will be equal to force acting on a system, or force acting on the body will be equal to not MA. F equal to MA is a special case of that. Just here, okay, no problem, no problem. Not change in momentum, rate of change of momentum. You write force acting on a body will be equal to force acting on a body will be equal to force acting on a body will be equal to rate of change of its momentum. Force acting on a body will be equal to rate of change of its momentum. This is Newton's second law. Newton gave the value of force with the help of second law. That force acting on the body. If any body is there, some net force is acting on the body. Due to that net force, body will have acceleration. Due to that acceleration, velocity of the body will change. If velocity will change, momentum will change. So Newton's second law says force will be equal to rate of change of momentum. Rate of change of momentum. And what is value of momentum? What is value of momentum? We represent momentum by P. And what is value of momentum? Mass into velocity. Is it a scalar or vector quantity? Is it a scalar or vector? Is a scalar. Vector means direction will also matter. When you write momentum, you have to always be careful about direction. So momentum will be coming as value of momentum is mv. This is how we represent. Yeah. So force acting on the body will be equal to rate of change of momentum. Okay, no problem. Or if you want, you can write this also as be focused. And always remember, whenever any quantity is related with rate, it will be of two types. If you remember, velocity was related with rate. So two types of velocity you got. You got instantaneous velocity, you got average velocity. In the same manner, we get two values of force. Instantaneous force dp by dt. If you remember, instantaneous velocity dx by dt, and average velocity delta x by delta t. So average force delta p by delta t. So these are the two values of force that we have. Instantaneous force, if momentum is given, someone asks you find the force acting on the body at t equal to 2 seconds. Find dp by dt. Put the value of time 2. You'll get the instantaneous force. Average force means delta p by delta t. And what is this delta p? What is this delta p? What is this delta p? Change in momentum. This delta p is change in momentum. Change in momentum. Change in momentum means delta p is change in momentum. Change in momentum means final momentum minus initial momentum, or you can say mv minus u. And this change in momentum in physics is so important that we have given a separate name for this. And this change in momentum is also known as impulse. Impulse acting on the body. The thing which is present on the board, from there at least 10 previous year question has been asked. I will talk about those questions slowly. So instantaneous force, the way instantaneous velocity was dx by dt, instantaneous force will be dp by dt. Sir, average velocity delta x by delta s. So average force delta p by delta t. Delta p means change in momentum. Change in momentum is final momentum minus initial momentum. Final momentum is m into final velocity. Initial momentum is m into initial velocity. And this change in momentum, you tell me what is the name given to change in momentum in physics? What special name given to it? Impulse. 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 Yeah. If momentum will change, I'm standing like this. Suddenly, if I will run, impulse is there. You say na impulse, running of the impulse in the nerve you study na. That is this impulse. That is this impulse. Yeah. Okay. Is it okay? Is it okay? Bolo 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 bolo. All these are vector. You have to be okay. We don't normally use, but actually they are vector. Ha. Okay. No problem. Ha. For example, I will give you one question. You try to find out. You try to find out. You try to find out. You write. Find net force acting on the body at t equal to that is impulsive force. That is different thing, Naveen. That is impulsive force. Impulse is different. Okay. You write find the net force acting on the body at t equal to 1 second. Find the net force acting on the body at t equal to 1 second. 4 and 3 means you'll get fx as. Always remember, this is NCRT part. This NCRT part बहुत important. If you open the chapter in NCRT, this is how they start the chapter. Always remember, if px is given, if you difference, you already know na, force will be coming as dp by dt. Why I am using differentiation here? Can you guess? Trishal said correct answer. Geetika, it is not 4 plus 3. They are vector. Px will give you fx, py will give you fy. So net force will come under root of fx square plus fy square. 5 will come. 5. Yeah, Raghu correct. Ashwak correct. Gayatri correct. First thing, Geetika correct. Why I am using differentiation? Why I am not using delta p by delta t? Why I am using differentiation? Joshita correct. Vivo correct. Why I am using differentiation? Particular instead, find the force acting on the body at t equal to 1 second instantaneous. So always remember, so we know f will be said dp by dt. So if you differentiate momentum of x, you will get fx. So fx will come, sir, dpx by dt. So from here, if you do, this will be giving you 4t. They are asking you at t equal to 1 second. If you put your fx will come 4. So fx will be 4. Similarly, you can find fy. Fy will be coming as dpy by dt. So fy will be coming as 3. Here time is not there, so directly you can say fy will be 3. So net force acting on the body will be under root of fx square plus fy square. If you put here, it will give you 5 Newton. Done, 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 done. Bolo, 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 bolo. Ha. So the basic question starting of NCRT, this is what is given. They have given px, py and previously asked also. This is also previous year question. I just changed the value. So tell me what is instantaneous force? Instantaneous force will be how much? Instantaneous force dp by dt, dp by dt. Average force delta p by delta t, delta p by delta t. Achha, what is this delta p? What is this delta p? This delta p is what? This delta p is what? Change in momentum. In physics, we have a special name for change in momentum. What is that special name? Impulse. Okay, no problem. Yeah, okay. Yeah. Now you can write. Achha, don't you feel? Okay, we'll move further. Don't you feel some graphical questions can be also framed from here? If you remember, slope of displacement time graph used to give you velocity. So in the similar manner, slope of momentum time graph will give us force. If you remember, area of velocity time graph used to give you displacement, change in position. Here, area of force time graph will give you change in momentum. Are you not getting idea? Like that only. You write graphical meaning of second law. We'll talk about graphically. Some questions are asked. Very famous questions are asked. Graphical meaning of second law. Graphically, what second law says. So first point that we get graphical meaning. Everyone has written. Shall we start graphical meaning? Shuru kare. Okay. Be focused. All this, everything. We have very limited time. We'll study only those things which are required for the NEET. So be very focused. Every single situation I'm discussing will come, not anything out of NEET. Everything exactly in the NEET. So we are not leaving. So because time is limited, yeah. So you have to be very focused. You cannot miss even a single situation. Always remember, I will simply say, the way we used to say, sir, velocity, slope of displacement time graph, in the same manner we say, force is slope of momentum time graph. And you know this slope is nothing, this slope is tan theta. Similarly, if you remember, area of velocity time graph will give you change in position, that was displacement. In the same manner, area of force time graph will give us change in momentum. That is also known as impulse. These are the two important graphical situations from Newton's second law. Same as your velocity and displacement. And always remember, when you find area, you have to be smart enough, because area above x-axis, if some area is above x-axis, that area will come positive, and the area which is below x-axis, that area will come negative. Is it okay? You tell me what is slope of momentum time graph? Force. So force will be equal to, if momentum time graph is given, someone is talking about force. So force will be equal to slope of momentum time graph. The slope of force is slope of momentum time graph. What is area of force time graph? Change in momentum or impulse. If you feel any confusion, relate with velocity, displacement and time. If confusion came in the exam, don't worry. Relate with velocity, displacement, time. You'll always get the answer. I will give you one question. I will give you 1-2 question, graphical question. Okay, no problem. You have to tell me, I'm giving you momentum time graph, means I will ask you about force. This is force A, this is force B. Force A is making 60 degree, force B is making 30 degree. And they are asking you find FA by FB. Same question you did, if you remember, same displacement time graph I gave you. I asked you velocity, same thing you did, same thing we had. Raghu correct, Gayatri correct, Ashwak correct, Naveen correct. Remaining people kya kar rahe ho? Geetika correct. I will simply say, sir, for momentum time graph given, now you want force now. I know, sir, force is slope. Slope means, sir, tan theta. So FA will become tan 60. FB will become tan 30. If you put the value tan 60 root 3, tan 30 1 by root 3, this root 3 will come in numerator. So answer will come 3 by 1. Or you can say 3:1. Done. Bolo. Everyone will get basic question. And don't think it will not come in the NEET. This year, if you saw the paper, na question came from here only. Na. They draw displacement time graph and they ask about the ratio of velocity. Na. Do you remember that question? Displacement time graph was given and they asked find the ratio of velocity. So this question can be easy, but only actually easy questions are asked in the NEET exam. Okay, no problem. As I will give you one more question. Come on. You write. Find impulse acted on the body. from 0 to 8 seconds. Find impulse acted on the body from 0 to 8 seconds. Find impulse acted on the body from 0 to 8 seconds. Have you seen this diagram previously? Have I drawn any diagram like this previously? We have drawn. Impulse will not have unit of Newton. It will have unit of Newton into second. Raghu is saying 30. Okay, Raghu. Two areas are there. Above area positive, below Ashwak also saying 30. Gayatri also saying 30. Suhas also saying. Prashid is saying. Litkida is saying. Trishal saying. Vivo saying. I think everyone got. Yeah. I'll simply say and always look what is given here and what is asked. Yeah. Shashul got, Lakshmi got, very good. Everyone got, no problem. No, Del also got, very good. Yeah. I will simply say, sir, what do you want? You want impulse. Impulse means change in momentum, sir. And this impulse is what? Area of force time graph. Now we have to find the area. So this area we have to find. I told you this is trapezium. If you want, you can find area by dividing it into two triangle and one rectangle. But directly, who will do that much? You can do like that also, no problem. Or we can directly, we know the area of trapezium. So its area will come, sir, half into sum of parallel side. So this parallel side, these are the two parallel side. This parallel side 6. This parallel side 2 to 4. That means 2. So 6 plus 2 into height. What is height? Height is 10. So I think this will give you 40. This will give you 40. And area below x-axis, this will come negative. We will see that half into base. Base you can see 6 to 8. That means 2 into height minus 10. So this area will come minus 10. That means you are going to get area 40 plus of minus 10. That will be giving you 30 Newton second. Done. Bolo. If I give you mass of the body and if I give you initial velocity, can you find final velocity of the body? If I give you mass of the body and if I give you initial velocity, can you find final velocity? Yeah, because this change in momentum is actually m into v minus u. If your mass is given, if v is given, u is given, you can find final velocity also. For example, someone said mass of the ball is 1 kg. Find the final velocity. If initial velocity is 5 meters per second, you will put here, you can get final velocity also. So not only impulse is asked, not only change in momentum is asked. In this type of graphical question, they also ask final velocity. Will you be able to find? Or if initial velocity is given, change in momentum is given, you can find final momentum, you can find final velocity. Done. Bolo. I will give you one more question where I will ask you to find the final velocity. And slightly tough, not tough. You have to just, one thing I want to tell you in that question, you write the question, famous question. Asked in JEE mains but not asked in the NEET. You write, a particle has initial velocity V naught. A particle of mass m has initial velocity V naught. And it is under the action of, a particle has initial velocity V naught. And it is under the action of a force. And it is under action of a force represented by graph. And it is under action of force represented by graph. Find its final velocity. Find its final velocity after time t naught. Find its final velocity after time t naught. Find its final velocity after time t naught. It is given that graph is semicircle, so that you can find the area of semicircle. Complete circle pi r square, semicircle pi r square by 2. So area will give you change in momentum. Area will give you impulse. Yeah, Ashwak has said correct answer. Lakshmi, you have to add V naught also. Nayak, that initial velocity only, area will not give you final initial velocity also there. Now if someone says particle starts from rest, then Nayak, your answer is correct. I think it is slightly tough to type. For all of you, it is slightly tough to type. Yeah. Naveen, that's wrong answer. Trishal, some mistake is there. See here, no problem, no problem, no problem, no problem, no problem. Be focused, be focused, be focused. Just see here. Okay, no problem. Huh? Geetika also said some answer. Let's see, no problem. Yeah, okay. Be focused, be focused. You are doing one basic mistake also. Understand how we'll talk, Okay, everyone is getting idea. Achha, can you tell me what concept I will use? For solving this question, force time graph is given. What concept I will use? Kya use karunga main? I will use concept of area. I know, sir. This force time graph, na, you want final velocity, initial velocity given. So I know, sir, area of force time graph will give us change in momentum, which is also known as impulse, which is, sir, m into v minus u. U is given v naught, which is m into, yeah, change in momentum means final momentum minus initial. That will be coming as m into v minus u. U is given as u naught. U is given as v naught. No problem. Yeah. Now area. Now what will be its area? It's a semicircle. Semicircle. What is area of semicircle? Area of semicircle will come, sir, pi r square by 2. Complete circle area pi r square. Huh? Trishal, okay, let's see. Trishal, no problem. Yeah, because this is a complete circle, area is pi r square. Here half of the circle, so I will simply say pi r square by 2. This is the area. This will be equal to m into v minus v naught. Okay, no problem. Huh? Now you tell me what area, what radius? So pi by 2 r square. Which radius you will take? What radius you will take? What is the radius? Here you have to take both as radius, because both are actually this you will not write here. What will happen? Two radius are there, both you have to give equal priority, otherwise dimension of force will not match. Are you are finding area of force, if you take only time as radius, then it will become problem. What you will say, sir, pi r square by 2 means pi r into r. This will be m into v minus u, v naught. Now out of these two radius, one radius will come with the help of time. One radius will come with the help of time, that is t naught by 2. Other radius will come with the help of force. Both are radius only, na baba. This also radius, this also radius. So you have to give, otherwise dimension will not match. Dimensionally your solution will become wrong. So what you will do, sir, two radiuses are there, sir, pi, that's why here r square is there. So that two radius will be involved. One radius will come with the help of time, other radius will come with the help of force. So it will become pi by 2. When you take with the help of time, radius will be t naught by 2. When you take with the help of force, radius will be f naught. This will be m v minus v naught. Now you can send this m this side and you can do from here. So this will become, pi f naught t naught by 4. Pi f naught t naught by 4. 2 into 2, 4. This m will come here. And this v naught you can send this side. Samjhe kya? Did you got some idea? Bolo, bolo, bolo. Bolo, bolo, bolo. You have done this type of thing. If you remember work done by the, in heat and thermodynamics, you are doing such work done. Yes, you are doing such work done. Whenever circle is coming, you are taking one radius with the help of volume, other radius with the help of pressure. Area of PV graph, work done. Bolo, bolo, done. Yeah, I'm giving you time of 5 seconds. See all this situation. We'll move further. I'm giving you time of 5 seconds. See all these situations and develop understanding. And this is used everywhere. Whenever you have two radius representing two different quantities, both you have to take. Once you complete, you can say done, sir. Achha, already people have said done, sir. Yeah. Okay, so you tell me what is slope of momentum time graph? What is slope of momentum time graph? What is slope of momentum time graph? Come on, Targa. Force. Achha, what is area of force time graph? What is area of force time graph? What is area of force time graph? Change in momentum, which is also known as impulse. Achha, tell me, if I give you force time graph and if I ask you find the final velocity, I've already given you initial velocity. Can you find there? Can you find there? Very easily, sir, because we'll know the change in momentum. Final momentum minus initial momentum. From there we can get. Yeah, okay, no problem, no problem. Now be focused, just here. Yeah, okay, no problem. Huh? Now we are going to move towards some more type of question based on impulse. Actually, the most important question which is asked from here is based from impulse. So we'll talk about some of the situation, and you already know what is impulse. What is impulse? What is impulse? Change in momentum. So we'll start some problems based on impulse. So just see here how we'll be talking. Yeah, we'll talk about some question based on impulse. Just see here. Okay, no problem. Huh? For example, assume this is the ground. This is ground. Okay, no problem. You have a ball in your hand. You throw the ball with speed v. Ball strike the ground. Mass of the ball is m. Ball strike the ground with speed v. That means momentum with which ball strike the ground is mv. After striking, ball rebounds back with the same speed. That means it rebounds back with the same speed, means again it will have same momentum mv. Can you tell me what is change in momentum of the body? Arey yaar, mv minus mv, final minus initial, final mv, initial also mv, change in momentum is 0. That is what Geetika is saying, correct? Remaining people are wrong. Arey initial momentum mv, final momentum mv, change in momentum mv minus mv, 0. It's not 0. Answer will come 2 mv. Arey baba, this is not 2 minus 2. You are not subtracting potato minus potato. You are subtracting to vector. That's why in the beginning only I said you momentum is a vector quantity. If you are taking this momentum as plus mv na, this momentum is minus. Dekho, direction. Momentum is a vector quantity. You cannot add and subtract normally. That's why when it came 3 and 4, you have taken momentum and force as under root of 3 square plus 4 square, because it was vector. So what will happen? What will happen here? If anyone asks you, find the change in momentum. This is mv, okay, no problem. But this is not mv. Now its direction is reverse na. So it is minus mv. So if anyone asks you, find change in momentum, final minus initial. So final will be your mv after collision. Initial will be minus mv. So change in momentum, which is also known as impulse on the body, will be 2 mv. Is it okay? Everyone got the idea? Geetika was saying, Gagandeep was saying 0, 0, 0. Did you got the idea? Change in momentum will not be 0. Momentum is a vector quantity. If our going momentum is mv, coming momentum is minus mv. So change in momentum will be 2 mv. Okay, no problem. So always remember, if anybody strikes and rebound, change in momentum will be 2 mv. Change in momentum will be 2 mv. Okay, no problem. And here they can also ask you, find the average force acted on the ball. So if force is asked, delta P by delta T, that will be 2 mv by T. You can also find, because they will give you time of contact will be given. They will say you for how much time ball remained in the contact with the surface. So if you know the time of contact delta T, you can find average force also. Done? Bolo, 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 bolo. Everyone got the idea? So change is always, you tell me, if a ball comes with speed v and it goes back with the same speed v, what is the change in the momentum? 2 mv. It's not 0, it will be 2 mv. Yeah, same thing happen in cricket also. Batsman, bowler ball the ball, batsman reverses the direction with a straight drive. You have seen which player plays the best straight drive? Acha, Suhas is saying me. Good. Suhas is Sachin. Yeah, Sachin straight drive was very great. Many times it used to hit the wicket itself because it was so perfect. Yeah, it was so perfect. Yeah. So bowler balls and he reverses the direction. He reverses the direction. There also change in momentum will be 2 mv. So this is how we can talk about this. How we, Acha, tell me. You tell me next situation. Okay. Yeah. Oh, okay. Shreyas Iyer is also playing. Yeah. Now Kohli also plays, but Sachin was of different level. You can ask from your parents because you have not seen Sachin batting that much. You can ask from your father. He will tell how great straight drive Sachin used to have. Yeah. And you can ask from your mother also. Sachin was favorite of mom also at that time because he used to play so nice cricket. Okay, leave it. Leave it. Okay, no problem. So this is how we talk about, and we can find everything. We can find everything here. Okay, we can find change in momentum, impulse also same, average force also we can find. Acha, you tell me. Acha, is it like that if you throw the ball with speed v, it will always rebound with the same speed v? No, it's not mandated, depending on the type of collision. So for example, if someone says you tell me, if the ball strikes the surface with a speed of 10 meter per second, mass of the ball is given as 2 kg. It rebounds back with a speed of, its mass is again 2 kg. It rebounds back with speed of 5 meter per second. Can you tell me how much impulse acted on the ball? What is the impulse acted on the ball? Yeah, you will simply say, sir, final momentum, mass into velocity. Sir, final momentum will come, mass into velocity, 2 into 5, 10. Initial momentum will come, sir. Initial momentum will come. Mass into velocity, mass 2, 10. So mass into velocity, 2 into 10, 20. So change in momentum, final minus initial. Final is 10, initial is 20. So impulse acting, that is a change in momentum, will be coming as minus 10. Is it okay? Initial Baba, initial mass into velocity 20, final mass into velocity 10, change in momentum 10 minus 20. Even a child can say answer will be minus 10. Sir, this is wrong. Yeah, okay, everyone started thinking, yeah, this is wrong because it's momentum. Always write the direction here only, otherwise you'll do the mistake. So point is mass into velocity. This initial momentum is not 20, sir. If this is plus 10, this is minus 20. Momentum is vector. Momentum is vector. So you will get finally 10 of minus 20. So impulse acting or change in momentum will be coming as 30. Done? Can I give you one question? Yeah, okay. I will give you a good question from here. Okay, no problem. Yeah. Achha, is it mandatory to give initial and final velocity, or can I tell you the height from where ball is dropped? If I tell you the height from where ball is dropped, you can find the final velocity now using motion under gravity under root of 2gh. After striking the surface, how much height it goes? If I give you that height also, you can find the velocity after collision now. So question asked, this is a question asked in NEET 2020. Same question, not NEET 2021. This question came. I will give you one question. Try to do by yourself. You write a ball of mass 500 gram. A ball of mass 500 gram is dropped from a height of 20 meter. A ball of mass 500 gram is dropped from a height of 20 meter. It strikes the ground and bounces back. It strikes the ground and bounces back to a height of 5 meter. If the ball remained in contact with the ground, For 0.1 second, if the ball remained in contact with ground for 0.1 second, find first you write impulse on ball, second average force on the ball, third average acceleration of the ball. For acceleration, if you have the average force by mass will give you acceleration. Find impulse on the ball, average force on the ball, and average acceleration on the ball. "20" means 10, 5, 15. 15. Ashwak, correct. Impulse will be 15. थोड़ा देख कर. You can do this question, easy question. Impulse will be 15. Then force is very easy. Yeah, Trishal, all answers correct. Trishal, all answers correct. Gagadeep, correct. Raghu, 15. Force will be 150. Yeah, force will be 150. 30, how, Trishal, you are saying? F average will come delta P by delta T. Delta P is 15. Time is given 0.1 second. So 15 by 0.1 second, 150. Ashwak, correct. Raghu, correct. Yeah, okay. Gagandeep, correct. Only boys are giving answer. What happened to girls? In calculation, girls are weak. Ashwak, correct. Suhas, correct. Yashwant, correct. You see, no girls have given answer till now. Only boys are giving. Now boys are making fun. Gayatri given answer but wrong. करो जल्दी. Little use of motion under gravity is there, that you already know. Say simple also. Geetika is given correct. First correct answer came from the girls. Remaining boys, what doing? Sindhu has given wrong answer. अरे बाबा, they will be added. Sindhu, अब क्या करूं मैं? Tattoo करवा लूं क्या? Momentum is a vector. She's subtracting 15 minus 10 again. 10 you are subtracting 10 minus 5. अरे it is vector ना बाबा, कैसे कर रहे हो? Okay, no problem. Still, if you have any problem, see for the last time. Khaja, correct. Now Khaja, second correct answer came from the girls. Boys, so many answers came. Girls, only 2 answers came. And now Sindhu has corrected the answer. No problem. Just see, it's what to be problem here. Just see, and please, whenever, yeah. Okay, Yashwant, Acha, Khaja is boy. Sorry, Khaja. Okay, Khaja is sweet. Okay, Khaja is sweet. Okay, no problem. So that's why. Okay, no problem. Trishal has said all the answers. Correct. No problem. Just see here. If you feel any doubt, see for the last time, you'll get the answer. Nothing to worry. And if you feel problem, draw the diagram. Drawing diagram is very, very important. Yeah. So what is said? Ball is dropped from a height of. Enter height dropping. Ball is dropped from a height of 20 meter. You know now when ball will strike the ground, you know this velocity. This velocity of striking will be under root of 2gh. If you put here, this velocity when it is striking the ground is coming 20. This is the velocity with which it is striking the ground. So you can write initial momentum, and while writing initial momentum only, write it negative. Don't wait for later on, otherwise you'll do the mistake in hurry. This downward momentum, write it negative only. Sir, mass 500 gram means 0.5 kg. So, sir, initial momentum will come. Sir, 0.5. Yeah, initial momentum will come. Sir, it is downward now, so I will take negative, sir. So, minus 0.5 minus 0.5 m into v. That is 20. So, initial momentum will come, sir, minus 10. After striking, ball is going to how much height, sir? It is going to height of 5 meter. And if you remember, if h max is known, you can find this initial velocity u, that is u square by 2g. From here, when you are substituting g, you are getting this velocity as 10 meter per second. That means final momentum, you know, sir. Final momentum, I know. It is already upward, so no need to write minus. It was downward, that's why we have written minus. So final momentum will come, sir, m into v. That is 0.5 into 10. So final momentum will come, sir, 5. Now, if anyone asks me, find impulse. Impulse means change in momentum. That is final momentum minus initial momentum. So impulse will be coming as 15 Newton second. If anyone asks me average force, someone came and he asked me, find F average. F average, I know, sir. Delta P by delta T. What is change in momentum? 15. And how much time of contact? 0. So delta F force will be coming as 150 Newton. If anyone asks me acceleration, I know acceleration of the ball you can find, Baba. Force you know na, average force you know na, you can find average acceleration. Average force by mass. So that will be coming as 150 by mass 0.5. That will come 300 meter per second square. Bolo, 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 done. Bolo. In NEET, they ask maximum this or maximum this. Average acceleration is not asked. Bolo, ho gaya. Twarga Chepandi. Do one more question, jaldi. Chalo, one more question, Twarga. Do one more question. I will give you the question which came in the NEET. Can I give you the same question? Exactly same last year NEET question. And I will just draw the diagram. I will not give in the form of language. Yeah. Okay. You have to tell, yeah. You have to tell me impulse on the ball. If you'll get root 2, you can use root 2 as 1.4. If root 2 will come somewhere, you can use it as 1.4. Trishal 34, Raghu 34, correct. Ashwa correct, Suhas correct, Srikar wrong, Del correct. This was the question. So easy question, you can see. Lakshmi correct. Pavani correct. I think everyone will get. Only this velocity you need. Sindhu, how 30 is coming, Baba? Going to 10 meter. That means final velocity will... Srikhar correct. Geetika correct. 34 will come. 34. So this velocity I can find. This velocity will come under root of 2gh. If you put this velocity is coming 20 meter per second. So what is initial momentum, sir? Initial momentum will come, sir. Mass into velocity. Mass 1, velocity 20. So 1 into 20, 20. But it is downward, sir. Vector. So minus. Khaja correct. 223,000 correct. Yeah. I'll simply say, sir, this velocity also I can find after striking with how much velocity ball will come. Because I know if h max is known, we know u square by 2g. So if you put from here, u will come under root of 200. That means 10 root 2. 10 root 2 means root 2 1.4 means 10 into 1.4 means after striking velocity will come 14 meter per second. That means final momentum I can find, sir. Since upward, so no need to put minus, sir. M into V. So 1 into 14, that will come 14, sir. Now change in momentum, final momentum, impulse means change in final momentum minus initial. So this will give you 34 Newton second. Done. Ho jayega sabse. Everyone will be able to get such questions. Twarga. I'm giving you time of 5 seconds. See all this situation, we'll move further. Acha, one question is given in NCERT. Just see, I will talk about that question. I will talk about that question related with cricket. If your paper setter is fan of cricket, he may give this question. Achha, you tell me, for example, question is asked like this. Question is asked like this. Same straight drive which I was saying you. Same straight drive which I was saying you. Assume a situation. Bowler balls. This is the hand. This is the batsman. This is the bat of the batsman. Achha, tell me if the ball of mass m comes with speed v, and after striking it goes back with the same speed mv, and if time of contact I give you t, can you find how much average force acted on the hands of the man? Yeah, at the hands of the batsman, 2 mv by t. Very good. If velocities are different, then for example, this is u, this is v, then mv plus mu. Are you getting? If velocities are different, then it will come, yeah, it will come m into v plus u by t. Bolo, 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 bolo. Same thing which I told already, but I did not say this question exactly. That's why I'm saying to you here separately. This is what I was saying you na. This is what we did. Different velocities. Finally, it will be added. Done. Will you be able to do? Bolo, 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 bolo. Achha, you tell me one more question is given. Achha, have you seen, you have also played, when you take the catch, automatically while taking the catch, you put your hands down. You don't take catch like this. Those who take catch like this, the ball is flying, I will catch it. They are never able to take the catch. When you take the catch, you do like this. Can you tell me why? Why? To increase the time of catching. When you increase the time of catching, now force decreases. Force, you write this point. This is explained in the NCERT with diagram. You write this point. While taking catch, hand is moved downward to increase the time. And reduce the force on the hands. If you open NCERT, one diagram is there, so they can frame question. To increase the time, to reduce the force on hands. As if you take the catch fast or if you take the catch slow, in which situation change of momentum will be more? Impulse will be more. In which case impulse will be more? Impulse will be same. Before catching, ball will have velocity. Once catch will complete, final velocity of the ball will be 0. So change of momentum will be same, impulse will be same, but force will be different. Because force is not only depending on impulse, it is also, so you write impulse will be same. Whether the catch is taken fast or slow. Impulse will be same. Are you getting the idea? Time of contact may be more, maybe less, doesn't matter. Impulse will be same. If time of contact is less, force will be more. If time of contact is more, then force will be less. Done. Bolo. Yeah, so question is asked like this. For example, is a question given in NCERT. They will say you like this. For example, is a batsman. This is not batsman. This is the hands of the player. If the ball is coming with momentum mv, if the ball is coming with velocity v, Achha, can you tell me once he will take the catch, what will the final velocity of the ball? Means initial momentum will be mv. Or you can say initial momentum will be, sir, downward. So initial momentum will be, sir, minus mv. Finally, ball will stop in his hand. So final momentum will become 0. So if impulse is asked, impulse will be change in momentum. Final minus initial, that change in momentum will come mv. If anyone give you force, time of catching, you can find average force on the hands, that is delta p by delta t, that is mv by t. Done. NCERT solved example is there. If you want, you can see that example. I'm giving you time of 5 seconds. See all this situation. We'll move towards one more part. One more situation we'll talk from here. Once you complete, you can say done, sir. Achha, you tell me. Achha, before moving further, I'll just ask you again. If the ball strikes the surface with momentum mv, rebounds with the same momentum mv, what is the change in momentum? What is the change in momentum? 2 mv, yeah, 2 mv. But you tell me, is it mandatory that ball will always strike the surface perpendicularly, or it can strike the surface making some angle also? That possibility is also there. Now, you are having a ball in your hand. You can throw like this. I can understand. Most of the time, you'll throw like this, but you can throw the ball like this also. So there what will happen, for example, someone says you, this is the ground, this is the surface, this is the ground. I have a ball in my hand. I'm going to throw like this with momentum mv. Ball will come, it will strike the ground, making an angle theta with the normal. This is the normal to the ground. Make an angle theta with the normal is perpendicular to ground, and it rebounds back. It rebounds back with the same momentum mv. Again, angle is theta. Can you tell me what is impulse? What is change in momentum of the ball? Here. Again 2 mv na baba. This final is mv, initial is minus mv, so change in momentum will be still 2 mv na. Either answer will be 2 mv or 0. So final mv, initial mv, change in momentum 0. Or someone will say this is mv, sir, previously you said this is minus mv, change in momentum will be 2 mv. Can I do like that? I cannot do. Previously I was doing because they were reverse of each other. Previously I was doing like this because they were exactly opposite of each other. That's why one was mv, other was minus mv. That's why change in momentum was 2 mv. Here they are not reverse of each other. You cannot do it directly. So see here change in momentum. How to find change in momentum here? And the very famous result you will remember also. Yeah, answer will come 2 mv cos theta. Anyone can suggest me the method to solve? Kaise karu? How change in momentum will come 2 mv cos theta? Component. Previously, same direction and opposite direction, no need to break into component. Now your momentum is slant. It is making angle. You will simply say, sir, I will break momentum into its component, and then I will check, sir. Then I will check what is happening. Yeah. If you see here, momentum mv has two components, horizontal and vertical. So if you see, yeah, Suhas, very good. Yeah, if this angle is theta, this is also theta, na alternate angle. You can see if this angle is theta, this angle also theta. That means momentum will have two components along the reference line, mv cos theta, perpendicular to the reference line, mv sin theta. This is your initial momentum. Yeah, answer will come 2 mv cos theta. Yeah, okay, no problem. Horizontal direction, no impulse will act. Yeah. Now if you see, this momentum will also have two components. If you see, horizontal and vertical. And you can see here now, if this angle is theta, this is also theta. Corresponding angle, parallel lines. You can see this parallel lines. So these are two parallel lines. This is the line connecting them. If this is theta, this is also theta. So now its component will come. This component will become along the reference line, mv cos theta. Perpendicular to reference line, mv sin theta. Now you want to find impulse. Impulse means change in momentum. Final minus initial. Now if you see, dhyan se, one of the most famous situation, 3-4 times this has been only asked, changing the value of theta. Given in NCERT, diagram is given. So be careful here. Yeah. Everyone understood this? mv cos theta, mv sin theta, which I did. Bolo, uttar ka. Now if you see now, change in momentum means final minus initial. Now when you subtract now, you see horizontal are same. If you see the horizontal component of momentum now, both places horizontal have same value as well as same direction. This is also plus mv sin theta, this is also plus mv sin theta. When you subtract them, they will cancel each other. Values are also same, directions are also same, they will cancel each. But if you see vertical, like the previous. If this is mv cos theta, this is minus mv cos theta. In horizontal direction, when you find change, horizontal values are also same, directions are also same. So when you subtract them, final minus here, they will cancel. But vertical, values same, mv cos theta, but direction reverse na. So if this is mv cos theta, this is minus mv cos theta. So when you use it, change in momentum will come mv cos theta minus of minus mv cos theta. So change in momentum will become 2mv cos theta. कुछ समझ में आया क्या? कुछ समझ में आया? हाँ गगनदीप, करेक्ट. देखो वहां पे horizontal value also same, direction also same, both are 2 and 2, so 2 minus 2 will give you 0, but vertical, one is 2, other is minus 2, so change will give you 4. That's why you are getting 2mv cos theta. So when angle is given with the normal, change in momentum will come 2mv cos theta. Put theta 0 here, you will get the previous situation which you studied. Put theta 0 here, this is what you studied now, you will get 2mv. Yeah, if f average is asked, then 2mv cos theta by t. Put theta 0. This is what you studied now. Everyone got the idea? Acha, you tell me, sometimes what happen? Angle is not given with the normal. If angle is given with the surface, then how much change in momentum will come? How much impulse will come? Now your angle is this. Any angle given is not your angle. When angle is given with the surface, you first find the angle with the normal. If this is theta, this angle will become 90 minus theta. So when you put 90 minus theta there, cos 90 minus theta will become sine theta. So it will become 2mv sine theta. Many times value of theta will be given 60 degree, 30 degree. You can get the answer. Srikhar correct, Joshita correct, all correct, Trishal correct. Done? Bolo. So before ending the class, we'll continue from here in the next class because I have class also. Okay. Before ending, I will just ask you two things. If the angle is given with the normal, what is the change in momentum? What is the change in momentum? What is the impulse? If angle is given with the perpendicular to the surface, 2mv cos theta, 2mv cos theta, 2mv cos theta, 2mv cos. If the angle is given with the surface, 2mv sine theta, because sir, now our theta will become 90 minus theta. So there if you put 90 minus theta, it will convert to sine theta. Done. Bolo. This is also known as glancing angle. This angle with the surface is also known as glancing angle. This angle with the normal, this is glancing angle. Okay, no problem. So this is how we have talked about. More situation we'll be talking in the next class. For today, we'll be ending. Okay, bye. Tata, bye. Take care. Bye.